Okay, 9.3, geometric sequences in series. Arithmetic were addition, subtraction. Guess what geometric is? Multiplication, division. And we're just going to say multiplication because we're going to multiply by a fraction. Okay? But it's the same thing. So we don't have common differences. We have common ratios now. So a geometric sequence has a common ratio. And when we found the difference, we took the second minus the first, the third minus the second, the fourth minus the third, right? So when we find the ratio, we're going to take the second divided by the first, third divided by the second, fourth divided by the third, and they all need to be the same thing. R cannot be 0. Well, why can R not be 0? Why can't your common ratio be 0? Can it not be 0? That means the whole thing would be 0 every time. And it's probably not what we're looking for. Let me know when you guys are good.
I'm good. I'm sure.
Okay, so determine whether these are geometric. So how we're going to do it, again, is take the second divided by the first, the third divided by the second, and so on. Okay, so 21 over 7 is what? 3. 63 over 21. 3. I don't know that, but it has to be 3, yes?
Yeah.
So I took 21 times 3, and I'm sure we all can do that in our head and get 63.
Yeah.
Okay? And for the next one to work, it'd have to be 3 again, and 63 times 3 would be 9 and 18. So is it geometric?
Yep.
So it's geometric, and your ratio is 3. So 25 or 20 divided by 25, 15 divided by 20, 10 divided by 15. I think we get 4/5 and then 3/4. Probably could stop right now, couldn't I? Is that geometric? No, it's not even arithmetic. Well, is it arithmetic?
Yeah.
Yeah, it is arithmetic, isn't it? It goes down by 5. So on your test, I will give you a sequence of numbers, and I will say write a definition, and I will not tell you if it's arithmetic or geometric. So I think it's pretty obvious that if you were looking for arithmetic or geometric would be, you'd say, oh, that's arithmetic. Yes. But it is not geometric. It is arithmetic. And D is -5. Okay, so C, 1 divided by 5, 2.1 divided by 1, and 0.04 divided by 0.2. So we better get 1/5, yes? Isn't the decimal for 0.2 1/5? Okay. And then I'd move this twice and move this twice. So 4 over 20 would be 1/5. So it's geometric, and R is 1/5. Now D, what do you notice about D that looks a little different than we've had before?
What goes negative, positive, negative?
Yeah, it alternates positives and negatives, right? Okay, could that ever happen with arithmetic? No. It can go negative and stay negative, or start negative and go positive, but can it alternate back and forth? No. So the only thing it could possibly be is geometric or neither, because if I'm multiplying it by a negative every other time, it's going to be a positive, isn't it? Okay, so let's see, we're still going to do it the same way. And then divided by 4 would be times 1/4, right? Okay, so I get negative, what, 2/3? Negative 2/3. And negative 2/3. So is it geometric? Yes? And your ratio is negative 2/3. Okay. So we're going to do division, yes, again. But we have to multiply by the reciprocal. So it's going to be 2/7 times 5/1 and 3/9 times 7/2 and 4/11 times 9/3. I think probably we're going to find pretty quick. Well, 9/3 does reduce, doesn't it? So 7/5, 10/7. So you get 10/7, 7/5. Can we technically stop after that one? Yeah. I usually check, and if the other one happens to be right, I go back and make sure I didn't do anything wrong. Does that make sense? But that is a no, and I would probably guarantee it's not arithmetic either, wouldn't you? Oh, because of here that turned into 1/3. Oh, that would be 7/6. Sorry, I added them instead of multiplied them. Do y'all understand that? You good? Okay, so here is your formula to write the equation, the rule, the whatever you want to say to get the nth term. So a sub n equals a sub 1 times r to the n minus 1. So our n minus 1 is in the exponent. When I look at an arithmetic definition and a geometric definition, should I be able to tell immediately if it's arithmetic or geometric? Geometric has an exponent, doesn't it? Does arithmetic? No. Will it ever? No. Not too bad. Same elements, right? Still a different place. Write the first 5 terms of the geometric sequence, which a sub 1 is 3 and whose common ratio is 2. Just like any other problem, I want you to write the rule, the definition, the equation, and then plug in 1, 2, 3, 4, 5. So a sub n equals, what's a sub 1? 3. And then r is 2 to the n minus 1. Now, I'm going to tell you right now, your book leaves it like that, and I do not like that. We don't write equations like that, do we? No, we never leave equations with an n minus 1. So when I do this, it is basically 3 times 2 to the n times 2 to the negative 1. Yes? Because the n minus 1. So what does it do when it has a negative exponent? Can't leave a negative exponent and answer, right? Right, reciprocates it, right? So that would be a sub n equals 3/2 times 2 to the n. Not bad. Does it look a lot better? Yeah. Now, in all actuality, you have the same answer. But the bottom one is how we would write an answer. We wouldn't write an answer like the top one. And so a sub 1, we plug in a 1. So it'd be 3/2 times 2 to the first. So your 2's reduce out and you get 3. Is that what we were supposed to get? Mm-hmm. So a sub 2, 3/2, 2 to the second. Now don't multiply it out because what's going to happen? One of the 2's is going to reduce out. So then I have 6. A sub 3, 3/2, 2 to the third. But I can reduce out one of them, right? So 2 squared is times 3, 12. So you guys find 4 and 5. Did you get 24 and 48?
I don't understand the.
The-
I don't know what you call it, but when you take the 2 out of the 2.
When you're reducing?
Yeah, I don't understand.
Okay, so you have 3/2, and then you would have 2 to the fourth. You could take one of the, because there's a 1 there, right?
Yeah.
And when you divide, you subtract, so that goes down to 3. It's this, and my, what do you mean how?
Do it again.
Okay, so 3/2 times 2 to the fifth. There's a 1 here, yes? So I can subtract 1. So it's 2 to the fourth. Guys, it comes back right here. N minus 1. Now, are all my answers multiplied by 2?
Yes.
Yes? Am I good? Okay, write the definition and find the 12th term of the geometric sequence. So what's the equation? You guys remember it already? A sub n equals, okay. So what's R? 3. Okay. And you did this even though you didn't know you did. Did you divide them and figure out? Yes, you looked at them and say, how do you get to them? So a sub n equals 5 times 3 to the n minus 1. But that minus 1 is going to reciprocate it. I'll write it all out again. So 5 and then be 3 to the n and 3 to the negative 1. So it'd be 1/3 times 5, so it'd be 5/3 times 3 to the n. your r is always going to be the base of that exponent. Always. Got me? Okay, then find the 12th term. So now all I have to do is plug in what? 12. So a sub 12 equals 5 over 3 times 3 to the 12th. But I can reduce out 1. So it's to the 11th. And I honestly don't know what 3 to the 11th is. Emma, you got your calculator handy? And just put it in your calculator all at one time. 5 times 3 to the 11th.
3 to 11 is 177, 147.
Times 5. I don't.
8, 8, 5, 7, 3, 5.
8, 8, 5, 7, 3, 5. Okay, on your test, if you have this problem, you're going to leave it where?
Like that.
Right there. Now, 2 to the 10th, do I expect you to figure it out? Probably. That's not too bad. Like 2 to the 4th is 16, right? So 2 to the 8th would be 16 squared, which you should know. 256. Okay, so if you don't know those, can you find them out really quick? Can you figure them out? Yep. So multiple powers of 2, I expect you to go pretty far with. Okay, 10th term of this. What's r going to be here? It's going to be a fraction? It's going to be a negative fraction. So here, and then it'd be 2/3 times 1/2. So what'd you say? 1/3, but negative? So r equals negative 1/3. Alex, why'd you say it's going to be a negative right away? It's alternating, right? You see a negative positive, so you automatically know. Now, should your work give you a negative? Yes. So don't get too upset about it. Okay, so a sub n equals a sub 1 times negative 1/3 to the n minus 1. So that's 6 times negative 1/3 to the n times negative 1/3 to the negative 1. So I multiply by the reciprocal. So it'd be 6 times negative 3, negative 1/3 to the n. So a sub n equals what? Negative 18. Do you see how still my r is in that parenthesis? Yeah. Okay, so now we plug in 10. So a sub 10 equals negative 18 times negative 1/3 to the 10th. Okay, so if I'm going to have a negative 1/3 to the 10th power, is it going to be positive or negative?
Positive.
It's going to be positive when I'm done, right? So I'm going to have negative 18 divided by 3 to the 10th. Is there a 3 in 18?
Yeah.
There's 2 of them, right? Because 18 would be 2 times 9, which would be 3 squared.
Or 6 times 3.
Well, yeah, but why do I want 3 squared? What's the bottom? 3 to the 10th. So I'm looking for 3s so that I can reduce out. You can do it the other way also if you want.
Wouldn't it be positive 18? Because then it's a negative times a negative.
Well, you got to do your power first. And when you take negative 1/3 to the 10th, it's going to end up to be a positive. Okay, so I can reduce 2 of the 10. So I get negative 2 over 3 to the 8th. Okay, so 3 to the 4th is 81, isn't it? 3 times 3 is 9. So 9 times 9 is 81. 81 squared is kind of a little bit, if you want to do it, that's fine, but I'm good with that. Okay. On your homework, work it out. Obviously, you have your calculators. Questions?
No.
Hardest part of that is simplifying it, isn't it?
Okay.
You set it up for me. You got most of the points already. Okay, the fourth term of the geometric series is 125. So a sub 4 equals 125. And the 10th term is 125 over 64. I hate that they write fractions like that, but that is how the book does it. And I want to find a sub 14 when I'm done. Oops. So I need to write a definition first and plug in 14, right? So how did we do these with the arithmetic? We took the 4 back down to 1.
We made it.
So a sub 1 equals 125. So that would make this a sub
6.
7.
Oh,
Yeah?
yes.
Okay. And we're going to plug it into a sub n equals a sub 1 r to the n minus 1. So our a sub n is 125 over 64. Our a sub 1 is 125. We don't know r. That's the point, right? What's n? 7 minus 1. Okay, so I have to solve this for r. That's what I'm doing, right? So I would divide by 125 or multiply by 1 over 125. My screen is acting up. So my 125 is reduced. So I get 1 over 64 equals r to the 6th. So now I have to probably take the 6 through it, right? Well, 64 is 2 to the... It's 2 to the 6th. Because 2 cubed is 8. So we have the 6 through it. So r equals 1/2. So now I take my r and come back to one of the two original equations. Which one would you like to do?
What?
We have to find our a sub 1. So we have to take our r and come back to one of the two original equations. Which one would you like to pick? The 125 or the 125 over 64? 125. Okay, so I'm going to just plug it in there. So 125 is my a sub n. equals a sub 1, what we're looking for. R we found was what? 1/2. And to the n minus 1, so 4 minus 1. So 4 minus 1 is 3. And 2 cubed is, oops. What's 2 cubed? I heard it. Say 8. 8. So multiply both sides by 8. So a sub 1 equals what? 40, carry a 4, 16, carry a 2, 1,000? Is that what you guys get? Oh, duh, because 8 times 1 is 800 and then 200. Yep. So I have a sub 1 and I have my r, so can I write a definition? So a sub n equals 1,000 times 1/2 to the n minus 1. So I'm going to multiply by the reciprocal of a half, which is 2. So a sub n equals 2,000. 1/2 to the n. And now I get to plug in what? 14. Okay, so we have 2,000 over 2 to the 14th. I'm sure there's some 2's I can reduce out of there, right? So 2,000 would be 2 times 1,000. And then it would be, I don't know what direction. You want to keep going 2's? You want to go bigger than 2? Well, 1,000 is 10 cubed, right?
Mm-hmm.
So 10 cubed would be 2 to the 3rd times 5 to the 3rd. Do you see how, like, us knowing how to break things down can make it a lot quicker? So I have 2 to the 4th. So I have 2 to the 4th times 5 to the 3rd. Look, so I can take out 4 2's.
Yeah.
So I have 2 to the 10th. We all should know 5 to the 3rd, which is what? 125. And 2 to the 4th is 16, 32, 64. And 2 to the 4th is 2, 4, 16. So I didn't know 2 to the 10th, but was it decently easy to figure out? Because I just did 2 to the 6th was 64, so I should probably use that again. And 2 to the 4th is 2 times 2, which is 4 times 4, which is 16. So I do challenge you to do some of that stuff rather than just automatically throwing it into your calculator. Now, check it. By all means, do check it with your calculator, but don't just go to your calculator to give you 2 to the 10th. Because you do 2 to the 10th a couple times in your assignment, are you going to remember 2 to the 10th is 1024?
Mm-hmm.
Yeah, it's not too hard of a number to remember. 256 was to the 8th, I think I said. So, is it the same thing we did with the arithmetic with the geometric? Are we doing the same things? Yes, wake up, guys. Okay. here's another one. We have the second term and we have the fifth term. We need to find the sixth. You want to do it again?
No.
Are you good doing it on your own? Let me see what I have. Yeah, this is all I have for today, so let's do one more. Other than they have recursive also, remember recursive? Like they give you initial condition and you say what's being happening, like what are you multiplying by? But I don't know if I gave you any of those today. Let me look. Because I don't want to do stuff we don't need to do. And I gave you... No, I did not give you any. Okay. So a sub 2 is what? Negative 18. And then a sub 5 is 2/3. Is r going to be a fraction? Yep. It's going to be a negative fraction probably, right? Maybe not. Oh, it has to be because you have negative 18 and then you have a positive, so it's going to have to be a negative ratio, right? Okay, so a sub 1, and then this would be a sub 4. So 2/3 equals a sub 1 times r to the 4 minus 1. So multiply by negative 1 over 18. So 9, negative 1/27. Is that right? Is r to the 3rd. Now, it's to the 3rd, so is a negative exponent okay? Yes? So we're going to take the cube root. So what's the cube root of 27? 3. So negative 1/3 is my r. So where do I go now?
Find a sub 1.
So do you want to use negative 18 or 2/3?
Negative 18.
Like I need to ask, right? So negative 18 equals a sub 1 r, which is negative 1/3 to the 2 minus 1. This is going to be nice because am I going to have to do a whole lot of work when it's 2 minus 1? No, because that's just first, right? So I multiply by negative 3. So a sub 1 is what? 54? Right? 24 carry a 2? Okay, so a sub 1 is 54. So a sub n equals 54. Negative 1/3. Can I jump from the n minus 2 to the multiplication, or the n minus 1 to the multiplication by the reciprocal? Are we good with that? No, not yet. Okay, so 54 times negative 1/3 to the n times negative 1/3 to the negative 1. So that means I multiply by negative 3. So a sub n equals negative 12 carry a 1, 162. Do we still see that r right in there? Yes. And now we plug in what? 6. So a sub 6 equals negative 162 divided by negative 3 in parentheses to the 6th. Okay, So negative 3 to the 6, is that answer ultimately going to be positive or negative?
Positive.
Positive.
How'd you get, I'm so confused.
What?
How'd you get there?
I plugged in 6. Because if I take negative 162 times negative 1/3, doesn't it give me this? Okay,
I'm asking.
but what I'm saying is this is over 1, yes, Emma?
Sure.
Look up. 162 is over 1, so it's 162 times 1, and it's 1 times 3. So that would give me this. Okay, so negative 3 to the 6 is also ultimately going to be a positive, correct? So I'm going to change this to a positive because my final answer is going to be a negative. So I need to figure out how many 3s are in 162. Guys, we got 162 by doing this, didn't we? Negative 3 times 54. So can we start with this? So 54 is 9 times 6, isn't it? Okay. So I have negative 3, I have negative, and then I have 3 times 9 times 6. So how many 3s can I reduce out? 4. So I have negative 2 as my numerator, and 3 to the second, which is 9. So negative 2/9. Which would make sense that my numerator stays 2. Why? What am I multiplying by every time? What's my R?
How did you get negative 2? Oh, wait.
You see it now? Okay. It makes sense that the numerator is not changing because I'm multiplying by negative 1/3. And so if I'm multiplying the numerator by 1 every time, is it ever going to change? No, only the denominator is going to change. Okay, so I mentioned recursive. I don't think you have any, but I am going to put it out there just so you know. Remember, recursive has initial condition, and then what you're doing, right? Okay, so I'm going to use what we just did as our problem. So a sub 1 equals 54, and a sub n equals a sub n minus 1 times negative 1/3. Okay, why would I know that this is recursive? Because that n minus 1, right? And so where am I starting? 54. And what am I doing every time? Multiplying it by negative 1/3. Okay, so it's just where am I starting? What am I doing? That's all you got to remember. Okay? Could I have like this here if I wanted to? Yeah. So you'd be multiplying it by 2 and then multiplying it by negative 1/3, which I don't know why you wouldn't just write negative 2/3, right? But, okay. So your assignment is on Google Classroom. It is all up